Tips and techniques. Organizing and running projects. Principle for running projects. Number 1. Every project needs a full-time leader with the overall responsibility and authority. Number 2. Define a set of measurable and non-overlapping objectives that are necessary and sufficient to accomplish the project goal or mission. Number 3. Assign project objectives of teams of 2 or 7 people with a hands-on team, leaders, and the appropriate mix of business and technical skills. Number 4. Tell the teams what to do but not how to do it. Number 5. Break a project work into tasks that are the week or less in duration and produce something and value to the business every 90 to 90 days. Number 6. Provide project office staff to work with a project leader and team leaders to update plans and budget. Supply chain process mapping. The project team should review the system performance criteria as described in the defined phase. The criteria will be some mix of performance targets from the 4 categories. Number 1, customer service. Number 2, internal efficiency. Number 3, demand and flexibility. Number 4, product development. Before starting to sketch out the detailed process flows of the new system, the project leader needs to lead people on the project team in brainstorming exercise on ways to meet this criteria. The project leader needs to encourage a free flow of ideas and the help project group into avoid falling into the trap of premature criticism. The dwelling on why things cannot be done. Focus instead on how things might be done. Generate as many ideas as possible for how to meet this performance. Criteria: these ideas are the raw material to be worked with and blended together to create a design for that new system process flows. Prototype this user interface for the system. Much has been written and said about the design of user interfaces for computer system. One of the most important concepts in that the user interface should be intuitively obvious. This means that person who. As you can see on the picture, this is the network service code website user interface. Homepage, order entry, company overview, member access, customer access, and supplier access. Order entry under is order login and order menu. Order menu is under select items, review order, and checkout. Customer access and reports login. Under of reports login is reports menu. And sales by location, sales by supplier, sales by volume is under reports menu.
Data display screen. The resulting report can be displayed either on screen or downloaded to a spreadsheet on customer's PC. Network Services homepage. This is the homepage for Network Services site. Different user options are selected by clicking on the buttons shown along the left-hand side of the screen. Reports menu. Customers can select the report they want and set report parameters such as locations, suppliers, and time period. A user who already knows the computer system functionality can easily learn its basics in 20 minutes. A well-designed system interface reduces training time. Create a prototype of the user interface based on process flow definitions and process decomposition diagram. Create computer screens that map to these flows and allow data manipulation.
In this phase, the project effort really ramps up. The full complement of people is brought on to fill out the project teams. Because of this, the weekly cost or burn rate on the project also rise significantly in the build phase. So, unlike the previous two phases, the cost of false starts and wrong turns now adds up very quickly.
Supply chain management. In the fall of 1999, Nikon Service Company reviewed and updated its strategic plan. The plan called for the company to build the first version of its web-enabled supply chain in 2000. The system have been enhanced and new features added since the system as market needs have evolved. Through its strategic plan process, network saw the biggest benefit of the gain was from using internet technology to electronically connect all of the different computer systems member companies. This would allow passing fields such as franchise order, invoices, and product masters quickly and accurately between customer members and manufacturers. With a system such as this network will be able to turn it into whatever electronic trending networks were involving in the market is served. The system to connect network with its member customer and manufacturers was named NetLinking NSCM. The second opportunity the company saw the act on was to make sales history data enabled via its website. Since network is the hub of the NetLink NSC system, a byproduct is that network gathered a lot of valuable information that can be used by customer members and manufacturers. The company decided to build a data warehouse that could be accessed through the fourth generation screen on its website. Many of network customers already had were building their own order entry system and they wanted to send the company franchise order directly from their system using either EDM or the Internet Net Link or NSCM would allow network to do that for those customers that wanted to enter order over the web. Network decided to use the use of website order entry package from a supply chain service provider named Riversource. Number three is developing supply chain system. Need to achieve the project objective within the time process called for in the project plan. Actively mostly tightly focus on the completion of specific sequences of tasks. This is that where good design and planning pay off hands-on in the pace the project effort really maps out. The full complement of people is brought on to fill out the project. Because of this, the weekly cost of burn rate on the project also risk significantly in the build phase. So unlike the previous two phase, the cost of false start false starts has wrong turns now added up very quickly. In number four, essential of supply chain management. The plan is the map of where the project is going and the progress made to date. If this map does not accurately reflect reality, then the people of the project will lose track of where they are. There is a previous tendency for people to hide bad news such as delays and cost overruns. Unless the project leader takes active steps to counter this tendency, the project will turn into table. People need to see that they will not be penalized for reporting bad news on the counter. They most they must be show that by reporting delays and potential cost overruns as soon as they perceive them, then can improve their chances of success. Early reporting gives everyone more time to respond effectively. People need to understand that the project office staff and her are there to help them then keep track of what is really going on and make timely decisions. If, if that one of the best way to get into trouble is to hide bad news because when the truth finally goes come out, there is usually very little if any time to respond effectively to the situation. And for the last number five, developing supply chain system. Somewhere in the design phase the project. In this way, they will be already have a understanding and acceptance of the need and benefits of the new system. Nonetheless, minor adjustment will need to be made to the system architecture and to the user interface during the beta test. The people who operate the system architecture will need to tweak different operating parameters to get the best response time and stability from the system. The people who design the user interface will need to seek the pilot group of business users and listen to their ideas for improvements. And also the business users who work with a system day in day out will have a different perspective on the system features than the people who design the build of the system. Minor minor inconveniences in the system operation can become major irritants to the people who have to use the system day after day. Those minor inconveniences should be fixed. As business people in pilot group test the system and make suggestions for adjustment and true edge are smoothed off in this process. Advocates for the system will emerge from among the pilot group. They will feel the personal connection to the success of the system because of the system will take on the loop and feel that is influenced by their suggestion. These are the people who will sell the benefits of the system to the rest of the company and who will often be the ones who train their coworkers in the use of the system. When the system first goes into product, the rollout for a big system One affects more than one area of the business or many people in the single area. May last a while, from 6 months to a year. There is not a lot of new development going on during this time, but this is service stream or minor enhancement and bug fix. The project teams can be snagged down, but the project leader need to stay involved during the system and facilitate help the rollout and response quickly of some expected obstacle areas.
In the real world, as the Chief Information Officer (CIO) of Network, I was tasked with developing a cost-effective and rapid e-business system infrastructure. This report outlines the strategic approach we employed. Based on the defined design, build process, I highlight the key phases and outcome of this project. Even before the defined phase was finished, work began on a design and build sequence to produce a beta test version of data warehouse that stored sales history data. This was completed quickly and provided the business with a valuable tool as well as proof that the technical architecture was viable. It also gave everyone a clear indication that the system development effort was off to a good start and would live up to expectations. A select group of consultants was brought into work with company IT staff. Four project teams were created, one team to design and build each of the four components of the e-business infrastructure. Two of the project team leaders were from the network IT staff and two were consultants. There was also a two-person project office team headed by one of Network's IT managers. The hardware and software component chosen for the system architecture was assembled and tested out by the teams that would use them. Data was passed between the components to make sure they could work together. Response times were tested under different data volumes to verify that the system could handle the expected amounts of data. When testing was finished, we had a solid design and there wasn't any talk of, we'll figure this out after we get into the build phase. Essentials of supply chain management. As each team finished the design phase of their work, they were all positioned to launch into their build phase. Each team had a clear set of design specification and they had been able to test and verify that the hardware and software they were going to use would meet their expectations. Because of this, it was possible for each team leader to work with the project office manager to create very accurate project plans and the budgets for their work in the build phase. The first version of all the system components were finished within 9 months and demonstrated to member companies and suppliers at the network annual trade show. The system were well received by network members and some members asked if they could use this system to support their own local business as well as to handle national account customers. So a set of enhancements to Netlink, NSCTM, and the data warehouse were quickly designed and built to let members use them for their local customers. In the last 3 months of 2000, the project team worked with network members to roll out version 1.0 of this system. At the end of 2000, network assessed its business situation and the market conditions. It defined a set of major enhancements to add to the system it had just rolled out. These enhancements were again designed and built within 9 months and demonstrated in the fall at the annual trade show. Exhibit 7.1 shows the time boxing sequence that was used on the project. Every Friday afternoon, the team leaders and I met to discuss the project. We spent several hours and reviewed the progress and the issues that each team was encountering. The project office provided accurate and updated plans and budgets to these meetings. We could all see the most current estimate of this and cost to finish each objective. We could see if work on an objective threatened to push beyond its time box or if it was likely to overrun its budget. Network Services e-business system development sequences. The development sequence was focused and tightly time-boxed. Work ran in parallel during the design and build phases, requiring good planning and coordination. Version 1.0 of e-business system infrastructure was created in 9 months. Based on positive reception and feedback from version 1.0, enhancements for version 1.1 were created. Further assessment of businesses needs to lead to definition of next round of major enhancement that created version 2.0 of the e-business infrastructure. Design step deliverables. Number 1. A detailed design for the business process flow of the system. Also, agreement among the people who will have to work with the system that it will meet the performance criteria expected of it. Number 2. A system prototype that specifies both the technical architecture and the user interface. This technical architecture must be shown to be capable of handling the data volumes and user demands that are expected. There must be a complete set of screen layouts, report formats, and specifications for all aspects of the user's interface. Number 3. There must be a detailed project plan and budget that accurately reflects the time, cost, and resources needed to build the system. Build step deliverables. A working system that matches the design specification and meet performance criteria. The building of the system should be scheduled so that there is something of value delivered to the business every 30 to 90 days. This means that certain pieces of the system must be finished and put into use before the entire system is completed. Number 2. A complete and updated set of technical design documents. The design documentation is analogous to the wiring diagram and structural plans of a building. Number 3. A complete set of operating instructions. The people who operate and maintain a system are different from the people who build system. The people who operate a system need to know how to bring the system up, bring it down, to do performance tuning, and do troubleshooting and operating maintenance.